Hello students, and welcome to part 2 of lesson 5, where we will learn about domain and range and learn to determine what domain and range is for a relationship. When I think about domain and range, I think about the beach. When I look at the beach, I often look at it in awe, and I think about how wide and how deep the ocean is, and just it amazes me. Domain and range connect to the width and the depth of the ocean because domain literally means a definition of the width of a relationship. And range is the depth of the relationship. And we'll look more specifically about what that means, but you can think about wide and deep when you think about domain and range. Domain, like we just talked about, is the width of the relationship. It is formally defined as the set of all possible input values. The key there is possible. So, for example, if we're talking about a candle sale at school, the only possible number of candles that a person can sell is 0, 1, 2, 3, and so on in this upward pattern by ones. That is defining the set of all possible input values. The only possible candles that you can buy are from 0 and up. You cannot buy negative candles. You can't buy half candles. You can only buy the whole number set. Range is the opposite. It's the depth of the relationship or the output values. Range is formally defined as the set of all possible output values. So let's say that we sold these candles for $10 each. What are the possible outputs then? Well, if you sold no candles, you would make no dollars. If you sold one candle, that'd be $10. If you sold two candles, that'd be $20. If you sold three candles, there would be $30. And so on in this upward by 10 relationship. All the possible inputs are called the domain. And remember, the domain is the input values, which we have learned when you write an order pair are the x values. The range are all the possible output values, and we've learned that output in an order pair is always the y value. In this lesson, we are going to learn to determine the domain and range for 4 different types of representations. We're going to look at ordered pairs, tables, mapping diagrams, and graphs, and learn to determine the domain and range. So let's first look at an example of how to determine the domain and range for a set of ordered pairs. Here are the ordered pairs. Now remember, domain is the set of all possible input values, and we know that input values are represented by the letter x in the ordered pair. And we also know that the range is the set of all output values, which are the second coordinate in an ordered pair. Remember, each ordered pair is an input value with a matched output value. So if we were to define the domain of this relationship, we know that it's a set of numbers, so you need a bracket to say it's this set of numbers, and the domain is the input values, or the x, so the x's are the first parts of the ordered pair, so the domain of this function is 2, 3, 4, and 5. Those are the possible inputs for this relationship. The range, as we know, is all the output values. If we look at an ordered pair, we know that the output values are represented by the y values, which are the second part of each ordered pair. So if we look at the second part of each ordered pair, we can see that the range is a set of numbers, and the only possible numbers that can output with this relationship are 1, 5, 9, and 13. So here's the input values, here are the output values. You find the input values by looking at the first part of each ordered pair, and you find the range or the output values by looking at the second part. Let's do another example to determine the domain and range for this set of ordered pairs. So the domain is the set, so we'll draw the set symbol, of all the possible input values. And we know that input values are the x in an ordered pair. So we have 7, 4, 1, and -3. So the only input values in this relationship are these four numbers. Now let's talk about the range. The range is the set of all output values, which we know are the y's in the set of ordered pairs. If we look, it outputs 11, 11, 10, and 10. And when we make our set list, we do not have to list them more than once. So the only output values are 11 or 10. This relationship always outputs either 11 or 10. All right, let's now look at how we determine the domain and range for a table. Now remember, we learned that a table is a way of organizing ordered pairs. Remember how we would draw the parentheses around and say this is the ordered pair represented in this table. So when we look for the domain, we are looking down the input column because domain's all the inputs, or the X column. Sometimes people will write X instead of writing the word input. So if we look at the domain column or the input or X column, the numbers that the inputs can be are -2, -1, 0, 1, and 2. These are the possible input values. Those are called the domain. Now let's look at the range. What can these inputs possibly output? Well, they can output 4, 1, 0, 1, which we already have that listed, and 4, which we already listed. So our range is 0, 1, and 4. Those are the only three numbers that can be outputted by this shown relationship. Let's look at another example. We again have a table, which we know is just a way of separating the inputs and the outputs of ordered pairs. So when we want to find the domain, we know that we are looking for the set of all possible input values. Well, to find that domain, put your set symbol since it's a set, and we want to look at the input values. We have an input of 3, 3 again, 3 again, 3 again, and 3 again. So the only domain number in this set is number 3. Every input in this relationship is a 3. Now, our range is the set of all possible outcome values, which we know are found in the second column of a table. So we have 1, 2, 3, 4, and 5. These are our output values. These are the numbers that can possibly be outputted by the domain. All right, let's look at determining the domain and range for the mapping diagram. Now remember, a mapping diagram is another way of organizing ordered pairs. This literally says 1, 1 as an ordered pair, 1, 6 as an ordered pair, 4, 4 as an ordered pair, and 2, 8 as an ordered pair. So as we look for the domain, which we know is the set of all possible input values, we know that the inputs of the ordered pairs are organized here on the left. These are the inputs, or the X, also known as the domain. So what are the possible numbers that are in the domain? We have 1, 4, and 2. Those are the only three numbers listed as inputs or listed as the domain. The range is the set of all output values, and when we look for output values in a mapping diagram, we see them here on the left. These are the outputs, also known as the Y values or the range. Those are all synonyms for each other. So the range is the set of numbers 1, 4, 8, and 6. Those are the only values that can be outputted by these inputs. Let's look at another mapping diagram. Remember, the domain is a set of all input values, and we'll find that on the left side of a mapping diagram. So the domain for this situation is 11, 12, 13, 14, 15, and 16. The range is the values that can be outputted by the inputs. We find the range on the right of a mapping diagram, so the range is -5, -4, -3, and -2, all found in the leftmost portion of a mapping diagram. And last, let's look at determining the domain and range for a graph. Now, notice, unlike all the other examples, we do not have many ordered pairs listed for us. In fact, we only have 2 dots representing ordered pairs. But this line is made of continuous ordered pairs. Everywhere on this line could be represented by an ordered pair. How many would be on this line? Infinitely many. So we do not want to list them all. Instead, we're going to describe where they lie on each axis. Now remember, domain is a set of all input values, and input values are represented by the x and are found on the x-axis. So if we kind of highlight down to where this function lies on the x-axis, we can see that it's all between 0 and 4. 0 is the smallest number it can be, so do you see how I put the less than sign? 0 is the smallest number that it can be, but the largest it can be is 4. This is a way of writing between 0 and 4. Now, do you see how it has closed dots? That means that these numbers are included in the graph. So we will also add equal signs under our values because it can go from 0 to 4, including 0 and 4. Now, let's look at the range. Remember, the range is the set of all output values represented by y. So let's take our highlighter with a different color and go over to the y's values. So we can see that the highest y value we have is 5, and the lowest y value we have is 1. So our function, or our graph, is always between 1 and 5 on the y-axis. So what's the lowest number it can be? 1. And what's the highest number it can be? 5. And can it be equal to 1 and 5? Does the graph touch at 1? Yes. And does it touch at 5? Yes. So we add our equal signs on it. So the domain is all the numbers from 0 to 4, and the range is all the numbers from 1 to 5. Let's look at another example. Now, remember, domain is the set of all input values. So if we want to figure out the domain, we have to figure out which values of x this function touches. So if I take any point on here and draw it down to the x-axis or up to the x-axis, you can see that the only place it lines up with is at x is 4. So the domain is actually just one number, 4. That is the only place that it hovers above or below the x-axis. Now, let's highlight the other way. Do you see how the arrows go on forever? That means that it goes on forever. So if we go over and trace it on the y-axis and we go on forever, that means that y can be any number. So the range is x. Any number can be the y. That's a little tricky. So let's summarize. If you're looking at ordered pairs, use this strategy, and if you're looking at graphs, use this